Hey there everyone, welcome back to another video. In this video, we are going to look at a paper, Chemistry, Paper 6, Alternative to Practical 0620, variant 63, October-November 2023. I'm not going to solve the whole paper, but I'm just going to go through on how you're supposed to answer the 6-mark planning and investigation. Okay, so let's start reading the question and then we'll get to how to solve it. So it says you are asked to investigate the effect of temperature on the rate of decomposition of aqueous hydrogen peroxide. Aqueous hydrogen peroxide decomposes to make oxygen gas. So now over here, I can immediately see that I'm investigating the effect of temperature, which makes this my independent variable. Now, since it's my independent variable, it's something that I'll be changing throughout my experiment on the rate of decomposition. So the effect of temperature will have, like changing the temperature will have an effect on the rate of decomposition. So that makes my dependent variable. But you know that the dependent variable is something that you measure. And what is it that I'm going to measure? I can't possibly just measure rate of decomposition, right? I have to do something so that it becomes the rate of decomposition. I don't know if you get me. For example, over here, we will measure how much of the oxygen gas gets decomposed over time. So over a set time, because it's a rate over here, right? Rate means something over a fixed amount of time, okay? So that will become my dependent variable. So it will probably be oxygen vol like produced over, let's say, set time, okay? So this is what I'll be doing to measure my dependent variable. To make oxygen gas, they have given you an equation here. Now, note that whenever you see oxygen in the question, right, there are high chances that you will have to measure the volume of the gas. Or it could be something else. That's not always the case, but most of the times. Now, the reaction is very slow unless a catalyst is added to hydrogen peroxide. Manganese 4 oxide is a catalyst for this reaction. Now, this is the main part. It's asking me plan an investigation to find out how the temperature of the aqueous hydrogen peroxide affects the rate of the catalyzed reaction. Your answer. This is also very important. This will tell you what your conclusion will be about. Your answer should include an explanation, okay? An explanation of how your results will tell you how the rate of reaction has changed. You're provided with this, and common laboratory apparatus. So, okay. Now I'm going to try and solve it myself, like try and answer it myself and we'll compare. Also, note that for paper 6, there are like these type of questions. There is actually no one fixed answer. Like some of the experiments do have one fixed answer, but most of them have different ways of getting the same result. So after the exams, if your friend uses a different method, you use a different method, but they both make sense, then they'll both be marked correct. Okay. So first of all, since I'm measuring like the aqueous hydrogen peroxide is the one that will decompose, I will maybe in a conical flask, I will add, let's say, 20 cm cube of the hydrogen peroxide. Okay. Now, the way when you're answering this question for chemistry, right, it's different from the way you answer for physics and biology. Biology is just a fixed procedure that once you do da 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 da, you'll get your marks. For physics, once you solve you answer what the bullets want, da 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 da, you get your marks. But for chemistry, you have to specifically specify each and everything. Okay. So what apparatus am I using? What is the volume I'm using? What is the concentration I'm using? What is the substance itself that I'm using? Specify everything. And it should be ordered in such a way that when an examiner is reading it, he's imagining what is happening. And then by the end of his imagination, he should have completed the experiment with you. Okay? So that's just something I keep at the back of my mind. So I've said in a conical flask, I'm added 20 cm of hydrogen peroxide. Okay. Now I also have to add manganese oxide, right? So I'll say add maybe 10 grams, 10 grams of manganese for oxide as it is the catalyst. Okay. Perfect. Then I'm going to say that how am I going to change my temperature between these, and how am I going to measure the oxygen gas, right? So I'll say add or connect a gas syringe to the top of the flask to collect the volume of oxygen gas produced. Okay. Then I would say that the temperature could be maintained. The temperature could be maintained like when you're doing that one experiment, could be maintained and changed between trials using a thermostatically controlled water bath. Now you could also add that conduct the first trial at 25 degrees Celsius. Okay, you could add that as well. Now I've done this. What is the next step that I'm going to do? It's a rate, so I have to measure the time it takes to for the amount of volume or amount of mass or anything for that. Okay, so I would say that using a stopwatch or using probably something like a clock timer stopwatch, wait for maybe 3 minutes, wait for 3 minutes, and after the 3 minutes, record the volume of gas produced. Okay, then I've used a stopwatch. I've recorded how much of the oxygen gas is produced. Okay, now how am I going to calculate the rate? Now the rate is what's really important. You could say that calculate the rate using the formula, and you could give a formula such as volume volume of gas produced over the time taken, which was our 3 minutes. Great. Now I've done everything. Now I have to provide an explanation of how my results will tell me the rate has changed. Okay, so at different temperatures, the rate is different. I'll say that first. Then I'll say that the temperature at which the rate is the fastest is the temperature. So the temperature which decomposes the hydrogen peroxide the fastest. Okay. Now you are going to get your marks still here. Like if you have mentioned everything properly, you have already gotten your 6 marks. But this is just to ensure that if the examiner is in a happy mood, he might just get an extra mark if you missed a point. So I would say repeat at each temperature at least maybe thrice and find average. Repeat the whole experiment at least twice. Okay, now I'm talking about experiment, find average, yeah, and then compare. Okay, at least twice and compare results. Then I will also maybe add a safety precaution. Safety precaution could include wearing goggles and gloves, perhaps. Okay, now for chemistry, you are most likely not going to get any marks for here, and you might sometimes get marks for here, but you're still adding it to show the examiner that you know what you're talking about. Okay, so now this was how I would have written it. Now let's check the mark scheme for it. Okay, now mark scheme says add known volume of hydrogen peroxide. We did that. Add known mass. We did. Do it in a flask. We did. Collected in a suitable graduated container. A gas syringe is perfectly a suitable graduated container. Measure the volume after set time. We did 3 minutes. Repeat at higher temperature. Higher volume is faster rate. Right. So you already get your 6th mark, but there's always a chance for the 7th mark, which you're not going to get 7 out of 6, okay? It's just that if you missed any point, if you have written like a 7th point, then if you missed any, let's say over here, this one, then it will compensate and you'll eventually get your 6. Now, that's not the only way to do it. You could have done time to get set volume of gas, mass loss in a set time, or time to get set mass loss, or measure time to stop reacting, okay? Now, any of these are perfectly correct and you will get your 6 mark. So this is how you are supposed to attempt the paper 6 question. Is it 4 most of the times? Yeah, the 6 mark question. Thank you for watching and I'll see you in the next video. Till then, ta-da.